The question is electric field due to thin sheet of charges as in the figure. And this figure, what we are seeing is it's a coordinate system. We are seeing x-axis, y-axis and z-axis. The charges are distributed here like this. In the first quadrant, we are having plus sigma. The surface charge density of this lamina in the first quadrant is plus sigma. And in the second quadrant, we are having minus sigma. And in the third quadrant, again, we are having minus sigma. And also in the fourth quadrant, we are having minus sigma. These are the charge densities which are distributed in the four quadrants of this coordinate system. And we have to find how much net electric field appears at this point P. Okay, so for this, what I have to think is, again I am redrawing this picture like this. So this is the way how I am going to take it. So first of all, I simply assume only the first quadrant. In this first quadrant, so no doubt this is the origin, and here is the z-axis, this is x-axis, and this is y-axis. And what I am going to take is, I am taking a small area somewhere here in xy plane, this one. And this area is dA, and dA is equal to, it is dx into dy. That means whose distance along x-axis is x and along y-axis it is y. So now if you want this one, this length, definitely this length is x square plus y square should be taken under root. Right. So now I am considering a point anywhere on a z-axis, say it is here. So this is our point P, the point what we have the interest. And now I draw a line like this, so this one. So this distance from here to here, from this small area dA to point P is what I am calling R. And that distance R can be calculated just by doing the Pythagoras theorem. R square is equals. So here this line should be perpendicular to z-axis, this line. That means this becomes hypotenuse. Okay, so hypotenuse. Therefore, r square is equals, what I must write is x square plus y square. Right. So x square plus y square, because it is under half, that means under root. So when I make it square, it is x square plus y square. And this distance, say it is z. From here to here it is z. So that means it should be z square. So means to say r square is simply x square plus y square plus z square. This is r square. This is our r square, this distance. Now you must be careful. The electric field at point P only due to this area, this small area, will act in this direction. In this direction. This is the elemental electric field dE. So dE is along this direction here, along R. So now if I say this angle is theta and this angle is also theta, then I can split this dE into two components. One is along vertical direction and one is along the horizontal direction. And the vertical direction component is definitely dE sine theta, and along horizontal direction what I can write, it is dE cos theta. And you must know, so you can neglect this one for our calculations further, because if I consider the same identical element somewhere in the fourth quadrant as well as in this quadrant and this quadrant, definitely all the vertical components get cancelled. So for that reason, so you can neglect the vertical component dE sine theta of dE. So now my concentration is all on dE cos theta, which is horizontal. So what should be the net electric field at P? So that is our question, and for that I have to go further. Now I have to integrate this dE cos theta to get the complete electric field at point P due to the first quadrant charge density. So that is what I am going to do now. So here now to get total electric field only due to the charges in first quadrant so I am making the integration like this. E1 is the total electric field at P. Okay, so E1 is the total electric field at P only due to the first quadrant. So this is equals. So what I should write is, it is dE cos theta. Our limit of integration must be restricted. So you must observe each quadrant, that means first quadrant, second quadrant, third or fourth, we should say the first quadrant extends from 0 to infinity. Okay, so it should extend to infinity, and on this side also, but it is limited here. So for that reason, only for the first quadrant, what I should put the limit is 0 to infinity. So this is how I am going to express the limits. So otherwise I can say this cos theta, so this cos theta should be, see this picture, in this picture the cos theta should be, so what it should be, so cos theta is here, right? So theta is here, that means this is how you must consider, this is the triangle, and in this triangle here is the theta and this is E, and the hypotenuse is R. Okay, so R. So from this what I can write R, so R is nothing but x square plus y square plus z square should be taken under root, right? So this is R. So now cos theta is simply what I can write is, it is z divided by R. Otherwise I can write it is z divided by x square plus y square plus z square taken under root, right? So it should be taken under root. This is cos theta. And now I put further things, that is in dE. Be careful, this dE. So this dE is what? So that dE is k is 1 by 4 pi epsilon O into the charge. So that charge is here. Okay, so the dq is the charge in the area dA. So that dq is written here and divided by distance to the point P from dq is R, right? From here to here it is R. So R should be made squared when you are finding the electric field. It should be squared in the denominator, right? So this is dE. Further I can put something here for dq. So dq is nothing but charge density into area, right? Charge density into area. So what is our area dA? dA is dx into dy. So now I am making substitutions for dA, that is sigma into dx dy, that I can put. So now finally what I observed for dE, so dE is, it is k into sigma into dx dy divided by what is R square? So R square is this much, x square plus y square plus z square. Okay, so x square plus y square plus z square, this much is what it is? It is R square. So now I am considering again this E1. So think about this E1 now again. E1. So E1 is equal to what I can write? So it is integration from 0 to infinity. How much is dE? dE is k sigma dx dy and whole divided by x square plus y square plus z square, and it should be multiplied by cos theta, and cos theta is, we already found it, it is z divided by this much, right? So z divided by this much. So that is nothing but what I can write, it is z divided by x square plus y square plus z square under root. Okay, so this much. So now when I combine all these things together, that is E1 will be is equal to, it is integration of k sigma z into dx into dy and whole divided by, it is simply x square plus y square plus z square to the power 3 by 2. This should be. Okay. So when I solve the denominator, I get this much. So x square plus y square plus z square power 3 by 2. And don't forget the limit. It is from 0 to infinity. So this is the thing even. But when we have to integrate it, so you have to look for double integration. What we are seeing is double integration. That means I can write this in a different way also. Right? So also, since I am having dx and dy, okay, so it should be area. That means I can simply write it even as double integration from 0 to infinity. Okay, so k sigma x dx dy whole divided by x square plus y square plus z square whole to the power 3 by 2. You should write this as this, because I have to integrate this small area in two different directions, x and y. So for that I should mention the double integration. Okay, right. So just forget about this one, and we have to write this in this way, this form. So now I am simply considering the integration for the element dx. Okay, so now E1 is equal to integration 0 to infinity. Well, so integration from 0 to infinity k sigma z dx otherwise dy whole divided by, what I can do is better I simply take dx divide by x square plus y square plus z square whole to the power 3 by 2 into dy. Right. So in this, so you should observe this much. And here, so you should know k sigma and z. K sigma and z are constants. So therefore, what I can write is E1 is equal to, I bring this k sigma z outside of every integration. So what the left things are 0 to infinity, and inside bracket what I should write 0 to infinity. It is dx whole divided by x square plus y square plus z square whole to the power 3 by 2 into dy. Okay, so I just brought k sigma z outside integration, every integration, and the all things, what the things which are left, so that is written here. Okay, now I have to think only about the integration inside this bracket. So for that you should know the rule. You should know the rule, that is what I am writing here. Integration of dx divided by, it is x square plus y square plus z square from 0 to infinity. So put so y square plus z square is equal to some a square. Say, this is how we can solve. So now on putting this substitution, this is dx divided by, what the things left, x square plus a square, and of course whole to the power 3 by 2 is here, 3 by 2 from 0 to infinity. This should be is equals 1 divided by a square x divided by x square plus a square whole to the power half in the denominator, and the limits are 0 to infinity. Now it gives a beautiful result. See here, when you put x is equals 0, x is the variable, and when you put x is equals 0, the bracket term will be 0. Okay, when you put x is equals infinity, so then what happens? 1 divided by a square into infinity divided by infinity square plus a square whole to the power half in the denominator. You know, in front of infinity square, a square is neglected. It is neglected. So that means what it happens, so simply it is 1 divided by a square, infinity divided by infinity square to the power half. So infinity to the power half, square to the power half is simply infinity. So this leads to 1. So that means the whole bracket answer is 1 divided by a square. So that means what I can write, so instead of this integration, right, so instead of this integration, what I can simply write that is 1 divided by a square. This is the answer. So what actually a square? A square is y square plus z square. So that means 1 divided by, it is a y square plus z square. This is the result of integration inside the bracket. That means what we had, so it is E1 which is equals k sigma z, and in the integration it is 0 to infinity, and we have one more integration inside. So for that the result is this much, 1 divided by y square plus z square, right? So 1 divided by, so y square plus z square into dy. That is nothing but the result of this integration, what we had in the previous page, right? So this is the result of the integration doing along x axis. Again we are having something here, that is one more integration, so only along y axis. So for that you have to think one more time, that is integration 0 to infinity 1 divided by, right, 1 divided by y square plus z square into dy. This will result 1 divided by z tan inverse x divided by, that means y divided by z, right, y divided by z, and the limits are from 0 to infinity. 0 to infinity. Okay, so when you put the lower limit, when x is equals, that means y is equals 0, when you put y is equals 0, that means this bracket term itself is 0. The whole thing becomes 0 because y is 0. So tan inverse of 0 is 0. So when y is equals infinity, that means you get 1 divided by z into tan inverse infinity. Infinity by anything is infinity. So that means you got this much. So now for what value of infinity, the angle we get tan inverse, tan of that angle is infinity. So it is 90 degree. So that means the result is 1 divided by z into 90 degree, that is in radians, it is pi divided by 2. Otherwise I can simply write pi divided by 2z. This is the result of the integration. That means therefore what I can write for even, it is k sigma z, the integration, the result of integration is pi divided by 2z. This is the result of integration what we had. So but what is k1? So k1 is, k is 1 divided by 4 pi epsilon o. I am keeping this sigma as it is and z as it is, pi as it is, 2z as it is. Now observe. So this pi and pi get cancelled, z get cancelled. The result is E1 is equals, right? E1 is equals, what the thing I am having now is, it is sigma in the numerator. This is 4 into 2, which is 8, epsilon o. This should be positive. So this is the electric field only due to the charge. Okay, E1 is equals plus sigma divided by 8 epsilon o. This is the electric field only due to the charge density plus sigma in first quadrant. Okay, so now you have to think, the total electric field in this direction will be in z direction, z axis, that is E1 is in this direction, and you must know E2 is in this direction because this charge is negative. Okay, and E3 is also in this direction, and E4 is also in the same direction. E4 is also in the same direction. Okay, the value of sigma is same in all the coordinates, but only the sign is different, right? So for that, what I have to write here is, so must be careful when you are writing. Finally, what we can write is, see, the quadrants are like this, and here is the first quadrant, and second, third, and fourth. This is the line of z-axis. Okay, at this point, the point P, what we have to do is the total electric field. The total electric field must be the electric sum of algebraic sum of E1 plus E2 plus E3 and E4. What I said, magnitude of E1 should be is equals to magnitude of E2 and magnitude of E3, and one more time magnitude of E4. Only the things are different, that is direction. Okay, so directions are only the different. So E1 is acting in this direction, E2 is acting in this direction, E3 is acting in this direction, as well as E4 is also acting in opposite direction of E1. Therefore, what I can write further is E total, right? E total is equals plus sigma divided by 8 epsilon O. Okay, so E2 is negative because here is plus sigma, here is minus sigma, here is minus sigma, and on that side is also minus sigma. So what I can write is minus sigma divided by 8 epsilon O. One more minus sigma divided by 8 epsilon O, and one more sigma divided by 8 epsilon O. Right. So when I combine all these algebraically, so E total will be is equals, E total will be is equals 2 times, right? 2 times sigma divided by 8 epsilon O. So E total is equals minus sigma divided by 4 epsilon O. This will be the answer for the question what we are having. This one, electric field due to thin sheet of charges as in the figure in this picture. The net electric field at this point is right. So this is equals at P. Okay, so at P, how much? It is sigma divided by 4 epsilon O. So this is the result of our derivation.